All right, so the fifth and last section of our probability chapter is probability models that use specifically two-way frequency tables. So in the last section, we used frequency tables where it was just one set of data represented in the frequency table. Two-way frequency tables display the frequency of data in two different categories and how they are related. Okay, so for example, if we go to this first example, if you look, this is a frequency table that displays the involvement in extracurricular activities at a high school versus the gender of the student. Okay, so we can use these to find even more specific probabilities. So in this case, the question is, what is the probability that a randomly chosen student is a female who is not involved in extracurricular activities? So the way that we write that probability is the probability of a not involved female. So to determine where we're looking at in this table and which numbers we're using, this last descriptor tells you which row or column to look at first. So you start here. So in this case, we're looking at just the females. Okay, so I'm going to highlight those. So we're looking at just the females, right? And then we're looking at the females not involved. So this is the second thing we look at. So the total number that we're using is that there are 259 females. So that is our denominator. And then we're looking at how many of those females are not involved. So not involved in activities is 120. So 120 out of 259, and I'm about 99% sure that that does not simplify, and it does not. So the probability of choosing a female that is not involved in activities is 120 out of 259. Right? So what this is called is conditional probability, which means the probability that an event will occur given another event has already occurred. Okay, so what that means is you're already assuming something has happened, which is the A in this situation, and then based on that, you're finding the probability of B. Okay, so it's always written as the probability of B, and then we read this vertical line as given A. So the probability of B given A. Right? So a couple more examples here. So respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What is the probability that a randomly selected person is over 60 years old, given that the person had no opinion on the state bill? Okay, so it's the probability that they're over 60, given they had no opinion. So we're starting here. So no opinion is a column this time. So we're looking at just this column, right? And then more specifically, over 60. So this number right here. So we have 40 out of, and then if we look at this, the total of no opinions was 100. So we can simplify that to 2/5. So the probability of someone over 60 given no opinion is 2/5. All right. So part B of this asks, what is the probability that a randomly selected person is 35 to 40 years old, given that the person is in favor of the minimum wage bill? So now it's the probability of 30 to 45, given that they're for it. So now we are looking at, somebody's trying to get a hold of me, at this column, and then 35 to 40, or 30 to 45 years of age. So then this number. So we have 200 over 780. which we can simplify. I don't feel like doing it in my head, so I'm going to use a calculator, to 10 over 39. And there we go. All right, and on to our last example, because these notes are kind of short. So a company has 150 sales representatives. 2 months after a sales seminar, the company vice president made the table of relative frequencies based on sales results. What is the probability that someone who attended the seminar had an increase in sales? So it's the probability of increase given that they attended. So now we're looking specifically at the column of people who attended the seminar, and then the number that increased their sales. So in this case, this one. So we have 0.48 over 0.8. We can make it 0.80 so that they both have 2 decimal places. All right. Which simplifies to 0.3 over 0.5. Yeah. So that is the probability of someone increasing their sales given that they attended the seminar. I think I simplified right there. My brain is already done with math. That is the last example. This is the last section of this chapter. Probability is super short because it's not really supposed to be in geometry, but it was on the air test. It always shows up on the air test. And even though we didn't take an air test this year, we still needed to cover the basics. So that's going to be it for probability. And that's it.